Hi, I'm Tim Gilbert. I'm your BUS320 instructor. I wanted to talk to you this morning about Chapter 3, Section 3, and another critical estimate of data that we calculate is called measures of variation. A couple ways to calculate that, but it's just as important as measures of center. You remember the measures of center were mean or average, and then median and mode. This time we'll focus on measures of variation, and there'll be a couple of measures, one in particular that's going to be helpful for you. Got our friend George Burns going to stop by a little bit later. He'll help us out. Okay. Our first measure of variation or spread is the range, maximum and minimum value. You remember with the actresses, maximum value Jessica Tandy, 80-year-old, minimum value Myrna Loy. So George Burns said she was 21 years old getting her Oscar. Well, we're going to talk now about something that includes all the values that are in the data set. If we take range, we're only looking at 2 out of the whole 76, and we've missed out on all the other deviation or estimates of spread that we've seen in the data. So now we're going to look at a standard deviation that uses all the values. This can look a little scary, but what's going on here is not so formidable as it first looks. What we really want to focus on is this area right in here, the individual x minus x bar, or the average. That just turned red as I clicked on it. Let me bring George up. Morning, George. Yes. Oh yeah, good morning. I recognize that from all my years in Vegas. We've got the individual x minus x bar and the individual value minus the mean. The sum of all individual values from the mean. Well, they're not quite true there because we include that squared term. But what's really going on is we're adding up or taking the sum of each individual minus x bar, or the average. Yeah, that's right, George. Let's look at an example. We've got 6 readings here of systolic blood pressure on the same patient, ranging from 122 to 147. Wow, that's not too good. Same patient, huh? 6 different med students. Let me know what med school that is. Well, here's what it looks like when we start to look at the deviation of each individual. We're not at standard deviation yet, but there's the first measurement, and we're comparing it to x bar, or the average. 122 minus 135, we got a negative 13. Then we did the same thing again. We got a negative 9 and a negative 9, a plus 8, a plus 11, and a plus 12. Well, that's pretty interesting. So we're saying we're not so much interested in the extremes as we're interested in all the data and how they compare to the average, how they deviate from the average. That's right, George. If we add up the deviations just as an exercise here to get a sense for what we're talking about and divide it by 6, we have an average deviation. That's really what's going on when we divide in standard deviation, although we use a little bit different value. We're really getting the average of the deviation around the average. Average deviation around the average. Let's take a look. Well, here I went into StatCrunch and saved myself those calculations and took the 6 data points. You recognize them under variable 1 here, starting with 122. Punched calculate, went to stat, and then under there basic or summary statistics. And I came out with an average of 135. That's good. That's the same as we had. and a standard deviation of 11.489. So that did all that individual calculating for me and a couple other things to come out with 11.489. Standard deviation is a better estimate for us to use with our probability curve that we want to work with a little later on. And here's what the calculation looks like if you took the time to put it in a table. You got the data, 122 negative or subtract 135, negative 13. Then I squared it, got 169. Then I took all the squares, all 6 of them, and I took the sum of, does that sound familiar to that sigma sign? The sum of the individuals minus the average squared. So that came down, I got 660 over 5 because I had to divide by n minus 1. Remember in the equation, n minus 1 down there? 660 divided by 5 is 132, took the square root and got 11.5. Same value that I got up here. I would encourage people to at least do this problem and push the pencil on it to get a feel for what's going on with the individual deviating from the average and then taking those deviations, squaring them, because if I didn't do that, I'd sum them up and they'd all sum up to 0. Because when you take deviations around an average, the lower deviations are always going to be negative and the upper deviations are always going to be positive. So, important properties of the standard deviation? Well, I got one. You use all the data. Good, George. The value of the standard deviation S is positive. That's good. It can increase dramatically. If we use that big data set with Jessica Tandy in there at 80, she really pulled the curve up on getting an Oscar. She would have a lot of deviation from the average. And the units of standard deviation are the same as the original values. That's fine. Now if we go 2 standard deviations and add it to the mean and subtract it from the mean, we get an idea of what the usual values would be. So we're saying that if you take the mean or the average, and in our case it was 135, and you add 2 standard deviations and subtract 2 standard deviations, you'd have a pretty good idea of what the usual values would be. And the likelihood that values would fall between those plus or minus 2 standard deviations, 95% of all values fall within 2 standard deviations of the mean. This is true in many, many data sets that we work with. So even though it might not be perfectly a normal kind of curve, that 95% holds up. And that's what it looks like if we put it in a general form. That little X bar down below, that represents 135. Plus 2 standard deviations, well, let's see, 2 times 11.5 is 23. That's going to be 158. Minus 2 standard deviations, 112. So based on those medical students that we had, we could expect to see off the same patient readings are ranging down to 112 and up to 158. Kind of scary, right, George? Sure is. I wonder what med school that was. So in this section we've looked at range, standard deviation, some estimates of standard deviation using the medical school students and systolic blood pressure, and then we attached it to a probability. That is the key aspect of standard deviation. When we use it with an estimate of center, an average or mean, and we add 2 standard deviation and subtract 2 standard deviation, we make a 95% statement that these are where the usual values would fall given the same conditions. So take care, enjoy your statistics, As hard as it is to say, it's more fun to do. So I'll be back with you in other sections, but I wanted to talk to you about standard deviation, and I wanted my good friend George to help out. Thanks, George.